This tutorial should be viewed maximized if possible, because it displays the Chan modeling system on a full display. Here we are going to move from start to finish on a simple example project containing a single pond with an outfall pipe. Let's create a new file, and then type in a short project description. Remember, this description can be up to 80 characters in length and will be used as a title on some printed output. Once a description has been entered, we need to specify a folder and file name for our Chan modeling project. We recommend you keep all models and their supporting data in the Chan projects folder. You should also create subfolders for organization and grouping of your project and support files, such as background images, photos, import data, and the like. In this case, we'll create an example projects folder. Then we'll move to that folder and name this project file, OnePond. The menu bar updates to provide us with options for moving forward. Select Layout to begin working with our model in schematic mode. Then press the spacebar to display the fixed menu bar. Before we start adding features, let's open the Options panel and turn on Feature IDs. These IDs are automatically generated using the current set of Auto ID instructions. With our labels set to display IDs for all features, we can turn them on, roll up the Options panel, and move it out of our way. Now, let's get to work on building our simple model. Click on the Reach command button to start. Select Culvert from the list of reach element types. Then, draw the reach from your pond location to its outfall. This is just a freehand sketch, so placement is not terribly important. A red label indicates that an element is not fully and correctly defined. Click on Select, then double-click on Node 20, the upstream node, to describe your pond geometry. Select Lake as the node type, then enter elevation values to describe the pond bottom, to set an initial water level, and to define a flood warning condition. Next, click on the Area command button. While entering geometry data for our pond, let's discuss 3 node types. We selected the Lake node type because we wanted to define the in-bank and out-of-bank geometry of the feature using an elevation versus area relationship. We would have selected Storage as our node type if we intended to use elevation versus storage values. This is less often the case, but useful for describing closed tanks and other special features. Channel nodes are similar to lake nodes in that their storage is defined using an area relationship, but those areas should only be defined for out-of-bank elevations so as not to double account for the volume that lays within the open channel section. We'll talk more about these and other node types and their usage in a separate tutorial dedicated to the topic. As we wrap up our pond geometry table, notice that a graph is displayed to help catch data entry errors. Double-click on Node 10 to define the downstream node. This is a tailwater node, and the initial water level will serve as a static boundary condition for the entire simulation. Double-click on Reach 20. Chan has already added a culvert to the reach element list and has populated several fields with user-defined default values. Just select the geometry type and enter the rise and length of the pipe. Chan uses a set of context-sensitive menus to present special functions such as to set inverts to node bottoms and to set inverts based on a desired pipe slope. Chan's context-sensitive features and functions are designed to make data entry simpler and more accurate. Close the culvert and reach element forms. Now let's add a basin. Click on the Basin command button and select the SCS unit hydrograph method. Click once to place the basin feature, and again to assign it to your pond node. Switch to Select Mode and double-click to edit the basin. Chan allows you to overwrite field values with user-defined defaults by typing Ctrl-O on the keyboard. Now enter the rainfall volume, the pervious curve number, the basin area, and last, enter a value for time of concentration. That's it for this example. Click on OK to close the basin form. The fact that all feature IDs are displayed in a black font indicates that our model network has been constructed correctly. Roll down the Options panel and click on the Control command. We will keep the default scenario ID and title, but let's take greater control over time setting. We'll specify a start time of 0, an end time of 30 hours, and our monitor interval will be 0.1 hours. Our hydrology and hydraulics output intervals will be 0.05 and 0.1 hours. Let's use a 10-second time step for computation. Close the form and click on the Simulate command button. The Chan Launchpad lists just the one scenario that we created. Select and launch the simulation. Runtime status is displayed until the simulation is completed. Now close the form to retrieve results. Simulation results can be accessed from the Options panel. Click on the Time Series command. We learned how to retrieve time series data during a prior tutorial, so let's retrieve and graph runoff to our pond. Now, let's retreat and plot the stage hydrograph for the pond. Finally, let's retrieve and plot the discharge hydrograph for the pond outfall. Returning to the Options panel, click on the Profiles command. We will explore this feature in detail later. For now, select the node and click Cancel on the Time Selection dropdown. Plot the profile, and then let's reposition the form on the screen. Click on the Play command button. A simulation playback control appears. Select the scenario in the drop-down list and click on an arrow button to advance the timer. As the timer advances, you will see a synchronized vertical dotted line on each time series graph. Select the scenario in the Profile Forms drop-down list and the water surface will be added to the profile plot, advancing with the playback timer. The timer control has short and long steps in both forward and reverse directions. As you step forward and backward in time, all active graphs display the common timeline. You can also select the loop command to continuously cycle through the simulation playback. Click on Loop Plus to cycle at a faster clip. While this is a simple one-node model, close examination of a single feature can help to understand performance at a bottleneck or diagnose a deficiency in a much larger system. You can click on Hold to freeze the frame and then deliberately step backward and forward as you inspect a critical point in the system. Here, we see that peak stage and discharge in the pond occur simultaneously, but at a point in time well after peak runoff reaches the pond. That's a quick start-to-finish example of using Chan to construct a model, run a simulation, and retrieve results. Click on Quit to close all graphs and dialogues and return to the main window. Save your file and close Chan. Until next time, where we will explore more features and use cases.